This video is Trig Notes 1.7 or Pre-Calc Notes 4.7, and the topic today is talking about the inverse of the trig function. Specifically, we're going to talk today about the inverse of the sine, cosine, and the tangent functions. One thing I want to talk about first of all is when we're dealing with an inverse, if you look at a graph, for example, the graph that you're looking at here is the sine of x, and we graphed that in previous sections. If I asked you, is the inverse of this graph a function, you should answer that with a no, because it fails the horizontal line test. So if I draw a horizontal line through here, you can see it touches the graph in more than one spot. So this graph, the inverse of this graph, will not be a function. But if I can actually just look at a portion of the graph, so if I can just look at just a portion of the graph, then I know that I could get the inverse of that graph to be a function. So not the entire graph, but just a portion of it. For example, if I was to look at only the portion of the graph between negative pi over 2 and positive pi over 2, so from here to here, from the top of the amplitude down to the bottom of the amplitude. If I was to ask you now, is that portion of the graph, would the inverse exist, or be a function, I should say? And you would say yes, because I can draw a series of horizontal lines through here, and it's only going to touch the graph in one spot. So if I want to make the inverse a function, I have to limit the domain. And that's what I've done here by drawing these lines at negative pi over 2 and positive pi over 2. So by limiting the domain to be x values that are between negative pi over 2 and positive pi over 2, we can now say that the inverse exists. So the inverse does not exist as a function for the entire graph. Instead, we have a limited domain, okay? And that's what we're going to be talking about in this section, is what specific parts of the graph will give us the inverse as a function. And I'm going to, in just a minute, show you those parts in a nice table. But before we get to that, let's talk a little bit more about the inverse function. If I asked you to find the inverse of the equation y equals the sine of x, what you would do is, remember from chapter P, I believe, when we talked about inverse functions, we would swap the x's and the y's. So x equals y sine of y, and then you solve this for y, and the way you solve it is you move the sign over. Well, the way we move the sign over is we take the inverse of it. Okay, and so whenever you see something raised to the negative 1, that means an inverse. So we can write the sign inverse by using a negative 1, or, and we'll see this written quite a bit as well, you could write it as the arc sine. So understand that if you see arc sine or sine raised to the negative 1, that's talking about the inverse. So by looking at the graph, like I did in the previous example, the graph showed us that there was only a specific portion of the sine graph that would work for the inverse to be a function. And I could do the same for the cosine graph and the tangent graph. And what I said was that for the sine graph, I had to limit the domain between negative pi over 2 and positive pi over 2. So really what that is, if this is negative pi over 2, if I go this way 90 degrees, and if I go this way 90 degrees, then what we're talking about is just this area of the unit circle that would work. In other words, that's quadrant 1 and quadrant 4. So we limit the domain for the sine inverse to only quadrants 1 and 4, for the cosine to quadrants 1 and 2, and to the tangent for quadrants 1 and 4. Now these are going to be very important for you to know, that the inverse of the sine, cosine, and tangent functions will only occur in specific quadrants. Okay? If we don't know this, then it makes it pretty difficult for us to be able to solve some of the problems that we're going to take a look at next. This is something I would star. This is something that I would also put on the back of my formula sheet. Because that's going to be a nice place to have it to help us with remembering where these inverses exist. So let's actually take a look at how we would actually use this information. If I asked you for the sine inverse of the square root of 2 over 3, basically what the sine inverse is asking you for, or the cosine inverse, or the tangent inverse is its request for an angle. That's all that the inverse is. What angle has a sine of the square root of 3 over 2? There's a couple ways that I can do this. I can use the unit circle or the reference triangle. I'm going to use the unit circle. So you're going to want to get out your unit circle. First thing you ask yourself is the sine inverse can only exist in which quadrants? Well, we said 1 or 4. So looking at the unit circle, look in quadrants 1 and 4 and tell me what angle has a sine of the square root of 3 over 2. So as I'm looking at the unit circle, and again, hopefully you're looking at it with me here, if I'm looking in quadrant 1, I notice that 60 degrees has a sine of the square root of 3 over 2. If I'm looking in quadrant 4, what I want you to notice about quadrant 4 is that all the sine values are negative. So it has to be in quadrant 1 because the sine is negative in quadrant 2. So that's the only answer that will be acceptable is 60 degrees. Okay? What about if I ask you this one, the arc sine of 1/2? So first thing I want to do is understand that I'm asking you for, give me an angle that has a sine of 1/2. So I need to limit my domain, or I need to limit my quadrants down by saying, okay, the arc sine only exists in quadrants 1 or 4. So again, look in quadrants 1 and 4 for a sine, again the y value, of 1/2. And as I'm looking at my unit circle, I'm noticing that it's 30 degrees. If I go down to the fourth quadrant, I don't have any positive 1/2 values for the sine. So it's got to be 30 degrees. One other thing I want to draw your attention to, if we're looking at the unit circle, we said that, if we go back to this example, if I looked at 60 degrees, 60 degrees had a coordinate point of 1/2 comma square root of 3 over 2. So that's where I was getting the sine of square root of 3 over 2. But if I also move to 120 degrees, that has a coordinate point of negative 1/2 square root of 3 over 2. So the question that usually comes up is, well, doesn't 120 degrees have a sine of the square root of 3 over 2? Yes, it does, but notice that this is quadrant 2, and the sine inverse does not exist in quadrant 2. So that's how we can eliminate this as being a choice, and I really only have one then actual answer for where the sine inverse would exist. So that's why it's important that we understand which quadrants the sine inverse or cosine inverse or tangent inverse exist in. Okay, let's take a look now at the cosine inverse of 1 over the square root of 2. It's a request for an angle who has a cosine of 1 over the square root of 2. So first of all, if we're dealing with the cosine inverse, I know that the cosine inverse only exists in quadrants 1 or 2. Again, that information is being found by looking at that chart on the previous page of the notes. The next problem that I'm coming across is I'm looking for what angle has a cosine of 1 over the square root of 2. Well, on my unit circle, I don't see 1 over the square root of 2 at all. But if I rationalize this by getting that square root of 2 out of the bottom, I recognize that it's the same as saying the cosine of the square root of 2 over 2. So looking at my unit circle, in quadrant 1, I notice that 45 degrees has a cosine of the square root of 2 over 2. If I move to quadrant 2, I notice that all of the cosines are negative, so my answer would have to be 45 degrees. Alright, my next example is asking me now to find the tangent inverse, or the arctangent of the square root of 3. Well, what I know is that there is no tangent on my unit circle. I only have sine and cosine values. But I'm looking for an angle that gives me a positive tangent, so I want to know where tangent is positive. I know that tangent is going to be positive in quadrants 1 or 2. So again, I'm looking for where tangent is positive. I know tangent is positive here. And I just realized that I know that tangent is positive in 1 and 3, and I wrote down 1 and 2. So tangent is positive in quadrants 1 and 3. And if you're asking how did I get that, I'm going back to section 4. So from section 4, we discussed where tangent and cosine and sine, where they're positive and negative. So that's quadrants 1 or 3. Where does the tangent inverse exist? The tangent inverse exists only in quadrants 1 and 4. So what that means is for both of these conditions to exist, where the tangent inverse exists and the tangent is positive, has to occur here in quadrant 1. So I can limit my information here to quadrant 1. So what I've done is I've inserted the first quadrant of the unit circle on here so that we can see it as a reference. I'm trying to find which of these angles, when I do the tangent, which is the sine divided by the cosine, because that's the formula for tangent, when I divide these out, is going to give me a square root of 3. So let's take a look at 60 degrees first of all. This is a cosine value, then the sine value. So do I have to take square root of 3 over 2 and divide it by 1/2 to get the square root of 3? Or would I have to take square root of 2 over 2 divided by square root of 2 over 2? Well, I know right away then when I divide that, that's going to be 1, so I can kind of eliminate that as a choice. Or would I have to use this one where I take this cosine and this sine and do, so let me say, versus 1/2 over the square root of 3 over 2. So which one of these is going to give me the square root of 3? Well, this was the 60-degree angle. This is the 30-degree angle. So all I have to do now is actually divide this out and see which one gives me a square root of 3. So if I do this one first, I'll get rid of this 1/2 by timesing by the reciprocal. So let me do that in a different color. And do this one, I'll get rid of this by timesing by the reciprocal, which would be 2 over the square root of 3. Well, I know here this is going to end up giving me a square root of 3. Here this is going to end up giving me 1 over the square root of 3. And again, I was looking for the square root of 3, so I know that it's got to be the 60-degree angle. So the only thing that I can do to help myself figure this out is limit which quadrant I'm looking at, which is quadrant 1, and then see which combination of sine divided by cosine gave me what I was looking for, square root of 3. And it happened to be that the 60-degree angle right here, when I took the sine and the cosine and divided them, gave me the correct tangent. For the next example, I'm looking for the sine inverse to be equal to a -4. And as I look on my unit circle, I'm trying to find an angle that has a sine of -4, and I'm not seeing anything there. So let's try this in our calculator. If I type this into the calculator, hit the sine inverse of -4, I'm going to get an error. And the reason for that is because on the unit circle, and in general, the sine inverse only exists when our x values are between -1 and 1. So this one, you can't have a -4 because -4 is not between 1 and -1. So this would be no solution. There is no angle that has a sine of -4. Looking at my next example, find the cosine of the arctangent of 2. So what I want to do first of all is deal with what's inside the parentheses. I'm going to draw a triangle that has that tangent of 2. But I first need to figure out where to draw that triangle. So first thing I want to deal with is where is the tangent positive? That's in quadrants 1 or 3. Again, that's from section 4 if you're struggling with how I'm coming up with that. The other thing I want to deal with is where does the tangent inverse exist, and that's in quadrants 1 or 4. And that's what we're talking about today. So that's how I found that from the chart on the front side of the notes. So in quadrant 1, let's go ahead and draw a triangle that has a tangent equal to 2. Well, here's what I know about a tangent. The formula for that is opposite over adjacent. So the way I'm going to want to do this is make this be a fraction. Have my opposite side, if my angle is here, the reference angle. This would be 2, adjacent side would be 1. Now I can go ahead and actually do what this problem is asking me to do, which is find the cosine then of my triangle. So to find the cosine of the triangle, I know that the formula for that is adjacent over hypotenuse. So to find this side, the adjacent, well, first of all, to do the adjacent side, we would have to do 1 over the hypotenuse, and to find that, so to find that side, and you'll notice I already did all the work here, I used Pythagorean theorem, so this would be the square root of 5. Can't leave my answer like that because I'd want to rationalize it. So when I multiply by the square root of 5 over the square root of 5, I end up getting a square root of 5 over 5 as my answer. So again, to kind of summarize what I did is I drew I found the quadrants that worked for this. Then I drew the triangle that had that tangent, and then I found the cosine of this triangle. So I've listed the steps out here which will be helpful for your notes, so I invite you to pause the video and write those steps down.